Few more rules we will see, guys. Let's say if A is greater than B, B is greater than C, what is the relation between A and C? So guys, we can say that if A is greater than B, A is on the right side of B. B is greater than C means B is on the right side of C. So combining these two, we can say that they follow this order C, B, A. So A is also on the right of C, which means what? A is greater than C. Okay, guys. For example, X is greater than Y and Y is greater than -10. So it means what? X is greater than -10. You can consider X as A. Okay, you can consider X to be A, Y to be B, -10 to be C. So A greater than B, B greater than C means A greater than C, X greater than -10, guys. Now some variations, like if suppose A is greater than B, B is greater than equal to C now. Then what is the relation between A and C, guys? So greater than only will come, or equality can also come. So guys, equality can also come. Why? Because in the case when A is equal to B, this is a special case when A is equal to B, and the same special case applies here. B is equal to C. When A is equal to B, when B is equal to C, A is equal to B is equal to C implies what, guys? A is equal to C. So therefore, here we have to use equality. Equality will also come. And definitely greater than can be established by the previous one that we derived. Okay? So that way it can be done. So what if now, if we place equality like if A is greater than B, B is greater than equal to C, then what is the relation between A and C? Greater than will come only, or greater than equal to will also come? So guys, as you can see here, A is greater than B. So even if B equals to C, A still would be greater than C only. It can never be, this equality won't come. Okay, so A greater than C only. So in the same way, it can be established that if I place equality here, A greater than equal to B and B greater than C, in the similar way it can be established, can be proved that A is greater than C, equality won't come. Equality will come only when we have equality in A greater than B also and B greater than C also, then only we will get A greater than equal to C, guys. Okay. Now the next rule that we will see is A1 is greater than B1, A2 is greater than B2. What about A1, A2 and B1, B2, guys? So if so guys, if there can be so many cases that A1 is positive, B1 is negative, A2 is negative, B2 is negative, and so on. We will take, if you take the case when A1, A2, B1, B2 all are positive, and B1, all B1, B2, they are all positive. Okay, so in that case we can, if you multiply them, greater than side will hold. For example, if you see 3 greater than 2, 5 greater than 1. So if you multiply 5 into 3 and 2 into 1, you will get greater than sign here, because 15 is greater than 2. So if A1 is greater than B1, guys, A2 is greater than, A1 is greater than B1, A2 is greater than B2, the product of A1, A2 would be greater than the product of B1 into B2. That we can say. And it can be generalized for so many inequalities, guys. Now, if I take a case like if A1 is greater than, if I place equality both the sides, okay, and now if I multiply, so would it be equality will come here greater than equal to? So yes, greater than equal to it will come, guys, because in the case when A1 is equal to B1 and A2 is equal to B2, in that case A1 A2 would be equal to B1 B2. So that we can say. And in the same way we can also establish that so now as usual, if I ask you, if here it is uh, if we take one of the inequality, if we place if we give equality sign to one of the inequality, then can we say that if you multiply the two inequalities, equal to sign will come here? Yes or no? So answer would be no, guys. Okay, so this equality won't come. Okay, A1 is greater, because in the case when A1 is greater than B1, A2 greater than B2, equality, since here there is inequality here, so here also inequality only will come, equality won't be coming. Okay, in order for this to have equality sign, both must have equality as discussed. If one has only exactly one has equality, then equality in their product won't be coming, guys. Okay, now the next rule, guys, is related to their addition, guys. So if let's say if we add the two inequalities, A1 gets added to A2, guys. Okay, A1 plus A2, so greater than B1 plus B2. When A1 A2 both are positive, it will hold. And this is for greater than, when both the inequalities are greater than. Okay, if equality is there in both the inequalities, so here also equality will also come. Okay, so that is also valid, guys. Let's take an example. If A is greater than equal to 3 plus C and C is greater than equal to 5, A and C both are positive, then find range of A. So since both the inequalities have positive numbers, okay, we can add the two inequalities. Okay, so A plus C greater than equal to, since both has greater than equal to, so here also we will have greater than equal to, and then 3 plus C plus 5, C and C gets cancelled from both the sides, so A is greater than equal to 8. So the range of A is, A belongs to closed 8 to infinity, guys. Okay, so guys, if x square is greater than 12 and 1 by y square is greater than 6, then x square by y square is greater than what? So since both the inequalities have positive numbers involved, we can multiply the two inequalities. Okay, we can multiply the two inequalities. X square by y square is equal to 12 into 6. So x square by y square is 72. So the answer is 72. Okay. Now let's see the meaning of square root function. Square root function is there is something inside. There is a function inside this square root. Some function which can be a linear function or any other function also, guys. So the examples of this is square root function is like 3 minus x under root of x square minus 7 and under root of log x and so on. There can be a multitude of square root functions that can be defined. Okay. Now, for example, if you take this function root 3 minus x, guys. Okay. Let's say this is some square, this function I defined as hx. Now, if I substitute x equals to 7, what value I will get? h7. So as you can see, it is under root of minus 4, which is not a real number. So it is unreal, not real, or it is something that we will discuss in imaginary numbers or complex numbers. Functions are generally those in functions what we substitute, it should give real, it should not give non-real or unreal values. So h7 we can say that it is not defined. Okay. Or we can also say that at x equals to 7, hx is not defined, guys. Okay. So now if I substitute, if I ask you what is h2, so if you substitute 2 here, now you will get under root of 1 plus under root of 1. If there is no sign, we take it plus only. So plus under root of 1 is 1 only, which is real value, and positive value because positive square root it is. Okay, because this plus sign is understood, it is always taken as positive. So plus 1. So h2 is real. Okay, at x equals to 1. So we can say that x equals to 1 belongs to domain of hx. Okay, and we can say that h equals to 7, it does not belong to domain of hx. Now the question arises, what is the meaning of this word domain, guys? Okay, so let's define domain, guys. So how do we define the domain of square root function hx? Okay, guys, so the domain of square root function hx is set of values of x for which hx is real. Domain of square root function is, guys, basically it's a set of values of x, all those values of x for which if we substitute it in hx, it gives real values. Okay, so that is the domain of square root function. So how do we determine domain of a function? So guys, so how do we find the domain of hx, which is square root of some fx, and fx can be any other function, maybe linear, quadratic, sine, cos, any other function. Okay, so since we know that if under root of anything is negative, this is non-real, because we substituted in the previous example x equals to 7 and we got under root of minus 1, which was not real, or we can also say that it was not defined. So what we need to ensure in order to find the domain of hx, which is under root of fx, that the inside what is inside the under root, that function must be given greater than equal to 0. So the fx must be greater than equal to 0. Okay, and you solve it, and whatever the guess, whatever the x that you obtain is that x set would be the domain. Okay, for example, if you take an example like what is the domain of fx equals to under root of 8 minus 2x square, guys. So 8 minus 2x square is the inside function, guys. Let's name it hx because it may create confusion. Let's say this is hx. So this inside function is fx. Okay, that we need to apply constraint greater than equal to 0. So if you solve this 2x square, and what we obtain after solving it, this becomes 4. 2 and 2 gets cancelled. Equivalently, x square less than equal to 4 we can write, which is x square less than equal to 2 square. X square less than equal to a square we can apply, which is minus 2 to plus 2. Okay, so x between minus 2 to plus 2. So the domain is minus 2 to 2. That the set of values of x for this. Okay, that is the domain. Let's take another simple example. The domain of under root of 7 minus x. So we have to apply 7 minus x greater than equal to 0, x less than equal to 7. Okay. Directly I will take another step here. X 7 greater than equal to x, x less than equal to 7. So the domain of this under root of 7 minus x is x belongs to minus infinity to plus 7 included. That is the domain. Okay. Now similar to the domain of an expression of a function, like we need to define the domain of an inequality also. Okay, like if for example a question is given, before that finding domain of inequality, let's take another rule of an inequality, which is this: if a is greater than b, what do you say about comment about a square greater than b square? Which sign will come? Whether it will be greater than or less than. So here if I take a constraint, if I take that a and b both are positive, so what about which sign will come? Let's say 7 greater than 2. What about 7 square greater than 2 square? So yes, definitely 49 is greater than 4. So a square greater than b square we can use, guys. Okay, so when a and b both are positive, we can say that a square, we can square both sides without changing the sign of the equality. In fact, if here equality is there, here also equality will hold. If equality is here, equality will be here as well. So what's the use of this? So the use of this is to solve inequality, square root inequalities. Okay, like for example 7 minus x greater than equal to 2. Okay, find x satisfying this. So under root of 7 minus x greater than equal to this, we can also say that equivalently before solving this question. So we can also show that since root a, which is plus root a by default, is greater than plus root b, so definitely root a and root b are positive. So if you square both sides, you will get A, and here you will get B without changing the sign. So if there is greater than sign, so greater than sign will apply, or in case if less than sign is there, then we will use less than equal to, so less than equal to will come, guys. So this root A greater than equal to root B, A greater than B after squaring, this we can use in solving square root inequality of this. So we can directly square, take square of this and solve, or do we need to take care of something else as well before solving it, guys? What do you say? So guys, in these type of square root inequality, we need to find the domain, and then solve. Okay, because the solution is the subset of the domain. See, if this is the domain, then the solution of the inequality would be a subset of the domain. Because first and the foremost, we need to ensure that whatever x that we are going to substitute, it needs to make this square root function positive. Okay, or real also, we can say here real and positive, they are the same, because it square root function will always give positive value, which is real. Okay, so if I'm saying real, it means it will give positive value, the square root function. So the thing is, we need to ensure that root 7 minus x, the x that needs to be substituted here, okay, that the first thing that we need to calculate is the domain x is less than equal to 7. This is the first thing, and then solve. So, and then solve means then we can use this fact, root a greater than root b, without changing the sign, a greater than b. Then we can safely square it, okay, and then take the intersection with the domain, okay, that I will tell you in the next step. So root 7 minus x, in the second step, what we need to do after calculating the domain, 7 minus x greater than equal to 2, we will square both sides, guys. So this squaring will remove the under root, so which will give 7 minus x greater than equal to 4. So in the next step, 7 minus 4 greater than equal to x, 3 less than equal to x, x less than equal to 3. So this is the solution. So the the solution is a subset of the domain, means we need to take the intersection of domain and what you got as a solution. Domain, okay, the final solution. This solution is the final solution. Okay, so this is not the final solution. This is the solution that we obtained after solving it. So this we need to take intersection with x less than equal to 7. Okay, so if you take the intersection, okay, so x less than equal to 3 is this, minus infinity to 3, and x less than equal to 7 is this, which obviously is a superset of x less than equal to 3. So as you can see here, the intersection of x less than equal to 3 and x less than equal to 7 will be x less than equal to 3 only. What I mean to say is this. This is the intersection. Okay. What if, see, so what we got after squaring it was the final solution also, but it may not be the case always. Like if I, in the same question, if I replace less than equal to greater than equal to by less than equal to, guys, okay, so already we calculated the domain, the first step, which was x less than equal to 7. In the second step, after squaring, we will get 7 minus x less than equal to 4. Okay. Now in this question I use less than equal to instead of greater than equal to. So this x greater than equal to 3 now we got. So now if you take the intersection, this is not the final solution. X greater than equal to 3 I plotted like this. X less than equal to 7 I plotted like this. Okay. So this and this perpendicular, if you say the common solution, as you can see, it is 3 to 7, which is not x less than equal to 3. It is rather 3 to 7, which was obtained by taking intersection with the domain. So in the second step, we have to take intersection with the domain after solving the inequality, and in that case, after taking the intersection, what you obtain after taking the intersection, what you will obtain would be the final solution, guys. Okay. So guys, what if I ask you root 7 minus x, now if it is greater than minus 2, so can we apply this root a greater than root b, a greater than b? Now here both were positive, so we can square. We did the squaring and we used a greater than b. But now as you can see here, this left hand side is positive and the right hand side is negative, guys. So what do you say? We already have calculated this is the domain of this. So can we square both sides? So the thing is, let's say if it is root 5 greater than, for example, if root 5 is greater than minus 3, if you square 5 and this will become 9, so we cannot write greater than, that would be wrong. But instead of, if it is minus 1, then greater than can come, but if it is minus 3, greater than won't come, it will be lesser than. So this we cannot square. Okay, and the thing is, there is no need to square, no need to square. Why? Because root 5 is approximately equal to plus 2.25 greater than minus 3. This is an identity, guys. So you need to do nothing. You don't no need to do. You simply label it as it is true. It is true. Okay, so that the same thing here also. Root 7 minus x for the domain x less than equal to 7 is positive. Okay, so it will always be greater than minus 2. So what I mean to say is the domain is no need to solve it, no need to square it. You can simply label this as true as well. This is true for all x belonging to the domain. What I mean to say is x less than equal to 7, no need to square, squaring is not required. Whatever the domain is the final solution, no need to square as well. Okay, so that way we can solve this. Now for example, if I ask you root 7 minus x greater than, instead of greater than, if I take less than minus 2. Now root minus 7 minus square root function always gives positive values. Positive values it will gives for the values belonging to the domain x less than equal to 7. Now this is positive, this is minus 2 is a negative quantity. The positive is lesser than negative is a false statement, guys. So whatever you substitute, you will get positive, and it is lesser than negative. It can never happen. It is wrong. It is false. So we will say that it has no solution, guys. It has no solution. Okay, or simply we can say that x belongs to phi. We cannot solve it. There is no need to square this as well, because this previous was truth statement, this is a false statement, guys. Okay. Now I will give you one question. Try this. X square minus 9 greater than equal to root 7. Solve for x, guys. So how you will do, guys? So yes, as usual, the hint, the first step is to calculate domain. We can use this root a greater than equal to root b, both are positive, so we can square both sides and we will get a greater than equal to b and then solve. So, and calculate domain means a greater than equal to 0. A here is x square minus 9, and whatever you solve after squaring it and the domain, you need to take intersection. That would be the second step. That is what we did in the previous examples. So guys, now let's head on to the solution part. Okay, so the solution, first we will calculate domain. So x square minus 9 greater than equal to 0, which gives x square greater than equal to 9, which is 3 square. So x square greater than 3 square means we will use the formula, which is x square greater than equal to a square gives x greater than equal to a, or x less than equal to minus a, where a is 3 here. So we will use this formula. So it gives you x greater than equal to 3 or x less than equal to minus 3. So this is the domain, guys. So this is what we got is the domain. Now we will square this. Root x square minus 7, x square minus 9, the second part, x square minus 9 greater than equal to root 7. Now we will square both sides. After squaring, this under root would be removed. It will be free from under root sign. Here also root 7 under root would be removed. What we would be left with would be 7. So x square greater than equal to 7 plus 9, which is 16. Okay, which is 4 square. So again, using x square greater than a square formula, x greater than equal to 4 or x less than equal to minus 4 we will get as answer. Okay, so this is what we got after solving it. The final solution is the intersection of the domain. So the domain was what, guys? It was greater than 3 and it was lesser than minus 3. Equality was there. This was okay. Or simply you can say that final solution is the intersection of x square greater than equal to 3 intersection x square greater than equal to 4 square. So if x square, we can apply logically, we can say that if x square is greater than equal to 4 square, obviously x square would be greater than 3 square only. Okay, so if you think that if x square is greater than 4 square, if x square is taken to be greater than 16, obviously x square will be greater than 9. So their intersection would be x square greater than 4 square only will come. So the final solution, we can say that x square greater than equal to 4 square, it would be minus infinity to minus 4, which is x less than equal to minus 4, and plus 4 to infinity, which is x greater than equal to 4. Okay, so this is the final solution. X minus infinity to minus 4 included, 4 to infinity, union 4 to infinity. Okay, that way we can solve. Now let me give you another question. Try this question, guys. Seven minus x less than equal to x minus 17. How you will attempt this, guys? try this. So the guys, the hint would be, now in the previous question only one square root term was there on the left hand side, but now here on the right hand side also a square root function is given. So the domain would be what, guys? The domain is something that we need to get which can satisfy this square root as well as this square root. So 7 minus x greater than equal to 0, x minus 17 greater than equal to 0, we need to take, in order to calculate the domain, we need to take what? Or and of these two. So we need to take the intersection of these two, because x should be something that needs to be satisfied to both root 7 minus x as well as root x minus 17 as well. So we need to take the intersection. So greater than equal to 17. Now here x is less than equal to 7, okay, which is this, minus infinity to 7, and here this one is greater than equal to 17. So if you take intersection, what you will get, guys? So yes, there is nothing common. So x belongs to phi. X belongs to phi, or we can say that there is no domain. No domain means before even solving it, we concluded that there is no x which can either go to this or go to this and make both of them positive. There is no such x. Means the domain of this entire equation is null set. It means there is no need to square and solve it. Okay, because if you square and solve, you may get some answer which would be a wrong answer. What I want to say is, if you square both sides, you will get 7 minus x less than equal to x minus 17. Okay, 17 minus x. Now x minus 7 minus x minus 17, it is minus 17 plus x. Now if you square this, so minus x we will take here, it becomes 2x, minus 17 will go on this side. So as you can see here, you may solve it, because so far you have always solved it. Okay, now divide by 2, you will get x greater than equal to 12. Now as you can see, x greater than equal to 12, you can take x equals to 12 or 13, but if you substitute in under root of x minus 17, 12, let's say if you substitute 12, you will get a negative value inside the under root. So this will make this as non-real number. So 12, 13 and onwards, they are not in the domain. So what we obtain after squaring and solving it won't be right. It would be a wrong answer. So the right way of solving it is first taking the domain, and if the domain is nothing, since we know that the final solution is the intersection of the domain, if there is no domain, then the question of finding it, solving it further is meaningless. Okay, so guys, you can try this question, under root of 8 minus x greater than under root of x minus 3. So again, as usual, the hint would be, we have to take care of the domain, which would be obtained by applying 8 minus x positive and applying x minus 3 positive and taking their intersection, which gives the intersection of these two will give you what? X greater than equal to 3 and x less x less than equal to 8. X greater than equal to 3 is this, okay, and x less than equal to 8 would be this. Okay, so if you take intersection of these two, what you will get is x between 3 to 8. That would be the domain. So since we obtain the domain, the first step, we will solve it, square it, and then we will take intersection with the domain to get the final solution. So root x minus x in the second step, root 8 minus x greater than under root x minus 3. We will do what? We will square both sides, guys. So it will remove the under root from both the square root functions. Now 8 plus 3, this becomes minus x, will go on the right hand side, it becomes 2x. So x less than 11 by 2, which is 5.5. This we will take intersection with x greater than equal to 3 to 8, 3 less than equal to 8. So x less than 5.5, 3 to 8 is this. Okay, both included, which is the domain, and x less than 5.5 is this. 5.5 is this. Okay, so if you take intersection with the domain, what you will obtain would be the final solution, which would be from 3 included to 5.5 excluded, because here 5.5 is not included. So this is the answer. Okay, close 3 to 11 by 2 open. That is the final solution of this question, guys. Okay.